So this video is for Math 70, and this is the third in the series on solving systems of equations. This is the third method we're going to look at, elimination of variables. So let's take a look at problem 2. We've got x plus y equals -2 and x minus y equals 6. Okay, so the trick here is what we're going to do is we're going to add these two equations together. Over here we're going to get 2x. The y's will cancel each other out. And over here, -2 and 6 make 4. Okay, now, having said that, let's back up for a minute and look at it again. Now, what's the justification for this? What exactly is happening? So let's just take the first equation here. And I think it's pretty clear. I think we can say without any hesitation, it's okay to add the same thing to both sides, right? We can add 6 to both sides. We do that all the time when we're solving equations. That's not a problem. But here's the thing. X minus y is the same as 6. So on this side, we're going to add x minus y, and on this side we're going to add 6, and we're adding the same thing to both sides. Okay, that's the key to understanding how these problems work. So really what we're doing is we're adding the same thing to both sides of this equation, and that has the effect of canceling out the y's, giving us 2x equals 4, and now there it is, x equals 2. So 2 plus y is -2, and y is -4. So there's our answer. X is +2, y is -4. Now you may be thinking, oh boy, can't we just use one of the other methods? Well, that's the thing about algebra. It's not so much about answers as it is about methods of solution. That's what we're really learning. When in most algebra courses, what we're doing is we're going over different methods of solution, different ways to solve these equations. And so it's not so much the answers that are important, although it is important to get correct answers. What's important is the method, okay? Understanding how the method works and how to do it correctly. All right, so that is question 2. These all start out the same. We'll see a little further down on the page we run into problems that are a little bit different. And I'll talk about that when we get there. So here, if we want to add these two equations together, see how the x and the minus x will cancel each other out. Here we'll have -2y. Here is -6. Divide on both sides by -2. Y equals 3. Then plug it back in and solve for x. X equals 4, y equals 3. All right. And when it comes down to it, so that's the thing, is that we've got these 3 different methods for solving a system of equations, sometimes by graphing, sometimes by substitution, sometimes by elimination. It depends on what kind of system of equations you're working with. One of these methods may lend itself in particular. Like when you see something like this, it's pretty quick and easy just to add the equations together and know that these are going to cancel each other out. Let's see here. Well, let's do problem 8. We start out 2x minus y equals -2. -2x minus y equals +2. Okay. And this is all set up and ready to go, right? If we add them together, those 2x's and -2x's will cancel each other out. Here we'll get a -2y. Here this is 0. Okay? And so divide on both sides by -2. Sometimes people get freaked out by dividing 0 by something, but do it on your calculator. There's nothing wrong with it. 0 divided by -2 is 0. It's when 0 is in the denominator that you have problems. So if y equals 0, right? 2x then is negative 2, and x is negative 1. So x is negative 1, y is equal to 0. Okay, what else? Let's see here. Problem 10. So problem 10 is where we run into a situation where we can't just go ahead and add the equations together. Well, we can. I'll show you what would happen there. Let's see here. Let's clean off the board a little bit. Okay. So, problem 10. We start out with these two equations. We can add these together, but notice that neither variable cancels out. Okay, so that's not really what we want to do to get started. So, a couple things that we can do, and I'll do both of them. Okay, you only really have to do one to get a solution for the equation, but since there's two possibilities, I'll talk about both of them. One thing we can do is if you look at the coefficients, this is a plus, this is a minus. If this were a plus 3y, then they'd cancel out really nicely. So what I'm going to do is I'm going to multiply this top equation by 3. So now it'll be 6x plus 3y equals 27. The bottom equation stays the same. Now we can just add them together. 8x equals 32, and so x is going to be 4. And then let's see, we can go back up. 2 times 4 plus y equals 9. And so that says y equals 1. So x is 4, y is 1. Now there's another thing we could have done here. Let's see here. If we have 2x plus y equals 9, 2x minus 3y equals 5. So the other possibility is we can go in and multiply either one of these equations by negative 1. To see how these 2's match up, but they have the same sign. So if we set it up so that they have different signs, then let's see. Then we'll have negative 2x minus y is negative 9. Bottom one stays the same. These cancel out. Then we'll get negative 4y equals negative 4. And so y should be equal to 1. That's what we got. And then we can plug the y back in here and get an answer of x equals 4. So it doesn't matter. You could do this, you could do that. We get the same answer. It's essentially the same thing. Okay? But the key is picking out, right, how to match these up with the same coefficient and opposite signs. That's the key. That's the key. All right. Let's look at a few more of these. Okay, let's see here. That was problem 10. All right, let's look at 14. 14, 7x minus 2y equals 4. 9x minus 3y equals 3. Okay, so neither one of those coefficients match up, right? And they have the same sign on both the x's and the y's. So we're kind of in a situation where there's no easy way out. I mean, what we're going to have to do is not that terrible, but it is a little bit more work than the other ones. And this is a little bit like building a common denominator, okay? If we multiply the bottom one by 2, that'll make this 6y. If we multiply the top one by 3, that'll make this 6y. Now, we've got to work on these signs too. So I'll multiply, one of them has to be positive, one of them has to be negative. So let's say down here, I'll multiply by 2, and that'll make this 18x minus 6y equals 6. Now to get the signs set up so that they'll cancel, to get opposite signs, here I'm going to multiply by -3. Okay? So the x's will get -21x, and then positive 6y equal to -12. Now everything's set up so that we can add these equations together. Over here we'll get -3x equals -6. So x equals 2. Then we'll come back over here, plug in 2 for x, and let's see here, 14 minus 2y equals 4. So let's see here, I'll subtract 14 on both sides. -2y is -10, and so y equals 5. So x equals 2, y equals 5. So that's the thing. If the signs are the same on both the x's and the y's, then typically you're going to have to multiply by a positive in one equation and a negative in the other. And it doesn't matter which one you do. The key is to get them to have opposite signs with the same coefficient so that they can cancel each other out. Okay, let's see here. Let's look at problem 16. 4x plus 3y equals 3. 10x minus 6y also equals 3. Okay. Let's see here. What are we going to do? Well, notice here, these have the same sign. These have opposite signs, and also 3 and 6. If I multiply the top one by 2, that'll set us up, okay? Because then we'll have opposite signs, and that will be a 6. So we'll get 8x plus 6y equals 6. 10x minus 6y equals 3. Add them together, 18x is 9. And again, don't fall into this trap and think that you have to divide by the smaller number. No, you have to divide by the number that's in front of the x so that we can get the x by itself. These cancel out, that's the whole point. We want 1x over there. Over here, a half or 0.5, doesn't matter. There's nothing wrong with it. Let's see, now we'll plug it back in. 4 times a half plus 3y equals 3. 2 plus 3y equals 3. 3y equals 1. And again, divide by the coefficient of the y. Don't worry that you're dividing a smaller number by a bigger number. That means your answers are fractions, and there's nothing wrong with that. Okay? And we can check this out too, right? This will be 2, this will be 1, that'll make 3. Here we'll get 5, here we'll get 2, 5 minus 2, also 3. Okay? All right. Well, let's keep moving. Okay, problem 18. Well, I don't see anything easy to get us started in 18. And what I mean by that is the signs are the same for the variables in both equations. We don't have any opposite signs. And also, there's no obvious multiple. Like here, I saw the 3 and the 6 and the opposite signs and was like right away just zeroed in on that, you know. Here, we don't have that. These are both plus, these are both plus, and neither one of these is a multiple of the other one. So if you want to keep your numbers small, you can work with the x's. Multiply the top one by 3 to make this 6. Multiply the bottom one by -2 to make this -6. You could do it that way. I'll work with the y's in this problem. So I'll multiply this one by 8 on both sides. And that'll make this 16x plus 56y equals 40. And then on the bottom, to get the signs opposite, I'm going to multiply by -7. And remember I said this is a little bit like, when you run into this situation, it's a little bit like making a common denominator. You have to multiply each equation by the number in the other equation. Okay? All right, so this will be minus 21x, minus 56y, and negative 42. All right, now it's all nice and set up so that the y's will cancel. Over here looks like we're going to get negative 5x, and over here negative 2. So divide on both sides by negative 5. X is going to be 2/5, which is also 0.4. And there's nothing wrong with using the decimal, that's just fine. Let's see here. So if x is 2/5, 2 times 2/5 plus 7y equals 5. So this is going to be 4/5 plus 7y equals 5. So 7y, I'm going to subtract 4/5 on both sides. You can call this, 4 1/5. Here's a place where the decimal actually works out really nicely, right? This is 0.8, 5 minus 0.8 is 4.2. And now if we divide on both sides by 7, we'll get y as being 0.6, which is 3/5. Okay, so we've got x equal to 2/5, y equal to 3/5. Let's double check. Maybe let's check that answer, make sure that it works. I kind of did that quickly in number 16. I think for this one, I will work it out. Not just do it in my head. Okay, so let's see here. So 2 times 2/5 plus 7 times 3/5, that's 4/5 plus 21/5, 25/5, which is 5. That's what we wanted. Good. 3 times 2/5 plus 8 times 3/5. Let's see here. 6/5 plus 24/5, 30/5, which is 6. Excellent. And there we go. Okay. So that's the thing. That's what I keep saying. Don't get freaked out if you get fractions for your answers, but do check them, right? If you're concerned and you're not sure if you did it correctly, check your answers. Okay. All right, let's see. I think we've got one more to look at here, problem 20. Okay. Similar scenario in problem 20, except here we don't have opposite signs, but we do have a nice multiple setup. Let's see here. 3x plus 4y equals 12. Okay. Well, let's see. So if I multiply the top one by 2, that'll match these 4s. But since these signs are the same, I'm going to multiply by a negative 2. Okay? So that'll give me negative 10x minus 4y is negative 12. And then 3x plus 4y equals positive 12. So these cancel out. Here we'll get negative 7x. Here we get a 0. Now they do cancel each other out in the same way that these do, but you can't just leave a blank space there, I mean, really what's happening here, and is always happening when I, draw a line through these to cancel them out, what's happening there is that we're getting negative 7x plus 0 equals 0. Well, we don't need the 0 over here. We do need the 0 over here because we need something on the other side to work with, okay? So, negative 7x equals 0, and again, don't get freaked out. 0 divided by negative 7 is equal to 0. So, if x is 0, that means y is going to be 3. Right? That's 0, 2y equals 6, and so y is equal to 3, x is equal to 0. Okay. So that's it for the methods of solution for systems of equations. I think that the next couple assignments will be word problems, and then from there we'll finish up by talking about rules of exponents, adding and multiplying polynomials, and lots of fun stuff. As always, if you have any questions, please let me know. Thanks.